Okay, so before the break, we were looking at having a camera follow our character around. In a 2D environment, we used, well, basically just grabbed the character's position, offset our camera a little, and then did the same thing. But that makes the camera jerk around a lot, which our characters need to do by the nature of games in many situations. But it's kind of off-putting when the camera does that. So we use linear interpolation to slow it down. And 3D is very similar. During the break, I went ahead and created a new 3D project to kind of apply the same thing. I'll just make a big cube and call this ground. I'll create a new material because the default material on the cube we can't change, but I can make a new material and get the zoom pictures out of my way, and then make this green so it looks like a ground and apply that to the ground. There we go. And what's a good size? 30 by 30. Oh, 30 by 30. Nice big spot for your character to walk around on, and then we'll make a character the same way, maybe a cylinder. It's a good shape for a character. Player will grab that, move its Y position up a little. It's a little above the ground, but that'll be close enough to look at the key points here. Maybe give it a color as well. Create a new material. I will go with a pink or a purple character today. That'll work. Did it not apply? There we go. And give our character, make a purple player, and we need some movements just like we had before. I don't want the capsule collider, get rid of that. We'll add a box collider will probably work for this. That looks like a pretty good size. And then a rigid body. And this is something I've found over the years is a lot of times when we're setting things up, we'll try to go right on the surface, and when we're eyeballing that and setting it up, we might get a little bit off. So what I found that I like to do is just start things where gravity is going to apply, start it a little above the ground so that when gravity starts to apply, it just, in the first frame of the game, it falls down to the ground. It doesn't have to be very far above the ground, just a little, because if our collider is already, like we get that a little too low and the collider is already colliding with the ground, then we can't move. So I found it's a little bit better just to start up a little so that in the first frame of the game, gravity pulls us down. Use gravity, that'll pull straight down, so that'll work. Interpolate, you can see in the physics, we have interpolate, just like the linear interpolation we put on our camera. Interpolate or extrapolate are the options, but kind of smooth things out. We don't necessarily need to worry about that here. I'll create a script to move that character around. A lot of the things we just did in 2D. Actually, what's in this? Actually, this will almost work and be a great example of similarities. So we come over here. Well, I'm going to clean this up and set these curly braces back the way I like them. Not really a necessary step, but like to try to minimize clutter here. Did I get too many curly braces? I did. Don't need that last one. Labeling curly braces is useful in update, in class, and something so we can keep track of those. So the big difference here, I'll just skip the start method and set up a public speed variable. Float speed is 0.1 F. We'll try that and maybe make some adjustments. And obviously the big difference is we need a vector 3 for our characters movement. Still the X one. We don't want to move that at all. But also we need to be careful that our y-axis doesn't drop us down where the collider's in constant contact with, like embedded in the ground, that same start issue. So .5 looks like it's definitely above the ground. So I'll do something like that. Just kind of looking for a good position here. Zoom thumbnails are back in my way. I'll go in this way. So instead of 0, I'll put that just a little bit above the ground. Make sure we don't have any of those collision things. And then this would be our old Z transform. And same thing here. Set the Y just slightly above the ground as a floating point number. Remember this time. And this needs to be our Z position, not the Y for 3D. And otherwise, we just say it's a 3D vector instead of a 2D vector. So you can see a lot of, that's a great example of the similarity between 2D and 3D. I'll close the old script so I don't get confused on two things called player. And then attach that script. Okay, that speed's probably too quick. Let's try 0.01. 0.05. Seems to be moving around pretty good. Probably go a little slower than that. Let's try 3. That looks like a good speed, gets us moving around, but the camera can't always see what we're doing, right? And that can be a bit of a problem. So we want to do basically the same thing. Where did that end? I think 0.03. I probably should have paid closer attention. I'll just put that, actually put that in the script. We could move our camera around to, say, a spot that sees everything. That's kind of what we did in the other example. But when we have a really, really big open world, that's not going to cut it, right? If we have an entire city for our gamescape and our player is just one person in that city, viewing the whole world is not going to cut it. So we'll need the camera to follow it. So again, make a C# script, call this camera. And this time I'm going to copy the whole thing. Move that back, but then all of this, I'll just replace with that we get rid of some white space so it all fits on the screen. So I made this note of this thing that we'll want. But does anybody see anything else that might need to be changed here? Anything that's not going to transfer nicely from 2D to 3D? So the look at thing is nicely named. So our camera is always going to try to point towards that. So that'll work. Our linear interpolation is starting at 50%. So we'll see what that looks like in 3D. But otherwise, all of our vectors are 3s, like Jacob pointed out when I made that typo. Which, yeah, when that happens, please don't hesitate to let me know, because I am talking and typing at the same time. So if you see something like say typo or something, that way I don't accidentally misinterpret what the question is or what the comment is. But we still want that linear interpolation. We'll try to get to the characters thing plus our offset pretty quick. We probably want more of an offset. We'll see what this looks like. Then really the only thing we need to add is just to make sure our camera is pointed in the right direction. So, the name target does not exist in the current context. Where's target? Oh, it's on camera. Oh, that shouldn't be target. That's focal object. Target would have been a good name for it, the thing we're trying to look at. Okay, no error messages. So when we run it, oh, whoops. Same thing did earlier. As always, we do have to attach the script before anything will happen. Now if we run it, oh, the exact same mistake I made earlier. Both parts of it. Attach the script and tell that script that we want to follow the player. Eventually, I'll remember to do those things. You can see now as our player moves around, our character kind of follows along with it. So that gives us that nice camera movement. And even when our player is moving around jerk real quickly, which is hard to see here, I'll get near the edge. When a player moves around really quickly, the camera doesn't jerk super quick because of that linear interpolation. We can maybe set up some conditions to restrict the camera where it can go. We don't really have any zoom or control this way. That was the other example I had in mind, because normally we would kind of control our camera angle by moving the mouse left and right, and maybe the scroll wheel to zoom in and out. At least that's what I have on the little example I have pulled up. So that you can see everything still works. That translated directly over to the 2D stuff. Might want to do a couple other things. Our offset, we might want to change that at times, and also adjust how zoomed in we are. So I'm going to copy from this example I have pulled up. This from a recent, well, not too recent, a couple years ago, but a role-playing game I put in where we kind of use the mouse to control where the camera is. I used left and right and scroll wheel to do that, instead of just the camera automatically following it from the same spot. So we might need to move our camera around. So I'm going to use the words, the normal ones terms. So yaw, pitch, and roll. So I'll make a private floating point number for our pitch. How to spell pitch. I'll just try 2.0, kind of a starting point. Is everybody familiar with those terms? It's rotating around an axis. So pitch is, I need to draw a picture on the board so this is consistent, because we've already seen that our axes can change. So using normal three-dimensional axes, I'll draw them kind of like this. We need rotation around different ones. So I'm going to sort of assume this is forward. So you can think of a plane. If I can draw, try to quickly draw a plane. Not a very good plane, but coming forward out this axis. So as we spin around this way, that's going to adjust our plane going up or down. I'll put a big F here for forward. And that's our pitch. As we spin around this axis, well, that's going to spin our plane back and forth. So that the roll, that's probably where you've heard those words before, especially on boats. Roll and pitch are a big deal. We steer planes by rolling. You may have heard those terms. And then around this axis, that's called our yaw. So yaw, pitch, and roll are the normal three-dimensional rotations. Just want to make sure and point out those numbers in case somebody wasn't familiar with them. So think about a plane. So it's the forward direction. If we rotate around that forward direction, that's the plane rolling back and forth. Our other horizontal axis, the one that would go out the wings of the plane, that's pitch. So that's the thing leaning to the left or the right, or sorry, up or down. Pitch would adjust where our forward direction is. And yaw is like spinning around the vertical axis. So I'm gonna go ahead and use the proper terms. I wanted to work them in some place, just in case you may not be familiar with them. They do, you may have heard them before, but they don't show up in everyday English quite so much. So I'll make a, I guess private's good. A private floating point number called yaw speed. So this is our really our angular velocity. Well, really it's speed, because it's not velocity until we add the direction. Normally positive is counterclockwise and negative is clockwise are the standard conventions in a math class, but we can label them whatever is most convenient for the situation. So it's not really an angular velocity until we add the direction in, whether we're spinning clockwise or counterclockwise. And this is going to be degrees, basically. So we needed something that lines up to our frame rate. So it's going to 60 frames a second. So we wanted to be able to spin halfway around in 1 second. We would need to go 180 frames, 180 degrees in 60 frames. So that would be like, is that just three more degrees every frame of the game would get us 180 degrees in a second. But but that's actually still a pretty quick spin. So I'm going to try something a little, I'll just try the number of angles and we'll see this. So if we want to spin 90 degrees, we might want to spin our camera to spin pretty quick because it's going to be out a long ways from our character. So really this is going to be a starting point. We'll pick how many degrees around our camera spins and then just adjust it from there. It's one that does need adjusted every time. And then I need a variable to hold the input. So when our mouse moves to say whether we're moving our mouse or not. So I'll make a floating point number for y'all input. And I'm just going to start that at 0 because it's an input. That one's going to change. Let's see, did I? No sense. So with this in mind, then, this really changes is our look at object. So instead of just looking at it, we want to change it a little. So we have that transform position. I'll go ahead and add that in. The position's implied if we don't put it, but I'll put it explicitly put it there because I want to add to it a vector 3 dot up multiplied by the pitch. So we're going to look at the thing we're at and then multiply it by how much we're tilted upward. Yeah, and we'll refine these numbers to the ones that look right here in just a moment. But sort of just little adjustments. And we can also rotate around things. So like transform dot rotate around is another one built in, just like look at. And we want to rotate around our our focal object position. And the vector 3 dot up. So wherever we're at, we want to keep the up direction that's aligned with the characters, and we'll spin around that based off our y'all input, which we can change. I should probably make those public so we can change them. I was thinking come back to the code and change them, but this way we can just change them in the interface. And yeah, then the other stuff having the example has to do with zooming. I was expecting more of an effect there. Let's try a faster speed. I'll try 180. Did I forget something? Oh yeah, have to change that y'all input. I forgot a line because the amount that we want to rotate is changing. So we do need to grab that. So before we do all this stuff, I'll just do it up here at the beginning of update. Y'all input is it needs to change. So we don't want to just assign it, because what I'm going to use is the same thing controlling our character. Input dot get axis, and I'll use the horizontal axis. So as our character moves left and right, we're going to we want to spin around the character. But that's a value 1 to -1. And we don't necessarily want to use just 1 or -1. We want to change by that amount each time. So in my example, I have minus equals that instead of plus equals that. We'll look at both of them and see the difference. Obviously, the difference is which way we spin with each one. So when we run this, so the up and down kind of do the same thing. Whoops. Let me try that again. Up and down do the same thing, but when we go left and right, our camera will spin around it way too quickly. So perhaps a better option for that, because we get a conflict. Instead of that, we could use our mouse, which is mouse.x. Is that right? I might have to check the input manager. Anybody remember what that is for our mouse? Mouse X. Looks like it's just mouse X with a space. That doesn't look right now that I've typed it. So run this. Oh, yeah, that's right. So to move the mouse left and right, we get some spinning around our character. So as we move, we can rotate around different directions by going left and right. Zooming in and out would be useful as well. So that's another one we probably want in our script. And I guess a very common way to do it is up and down for the zoom in and out. I'm going to use the scroll wheel, because I'm pretty sure we've seen the mouse X and the mouse Y would be exactly like that. But none of the examples in our textbook had a scroll wheel. So let's use the scroll wheel somewhere. And to do that, I'm just going to set up some numbers for a zoom. Just manually make a zoom. So a private one, that way we can only adjust it from the mouse. Floating point number called current zoom. I'm going to start that at 10. And in the example I'm copying from, I also have a floating point number in here for zoom speed, which I assume I put in there because it was acting funny. And I set it at 4. So let's put that in there and see what happens. Oh yeah, we never did check the other thing. Let me real quick switch this to a plus instead of a minus. Y'all know how to do checks like that. When I run the game, now if I move my mouse to the left, we're spinning to the right. And vice versa, if I move my mouse to the... Well, I said that backwards the first time. If I move left, we spin right. If I move right, we spin left. So that's why this was a subtraction reassignment instead of an addition. Is the way forward and backwards translates into clockwise and counterclockwise reverses on us in the unity labels. So I have zoom speed, and we probably don't want to be able to zoom forever. So also make a private float, which could be a constant, but maybe min zoom of 1, and a private float for a max zoom to sort of clamp our values in. 20 is probably good. Again, pick a starting point and kind of see what the numbers do from there. So when we get down here, after the yaw input, I'm going to do the same thing for the current zoom. So current zoom, I'll adjust that by the input axis, input.get axis. Yes, I shouldn't abbreviate when I say it. And this time we'll use the mouse scroll wheel. How's that spelled? Oh, capital W. So mouse scroll wheel, but only one space in there. So capital letters, but I guess they treated scroll wheel as one word. I always think of that as two words. Microsoft Word has never underlined it in red when I've spelled it with two words, but I guess there's a one-word version as well, since it's so common. But that's why I put this in here. We can try it without it. But instead of doing that directly, that's a value -1 to +1, which will be really, really slow, right? Like in most of our computers, when we set our scroll wheel, you can see line 34 is there. When I scroll up once, it's going one line, but a lot of times that's, in a lot of situations, one click at a time is too slow. And zooming in and out on our game is one of those situations. So we probably want to do more than one click. So instead of doing plus or -1, we'll just multiply that by 4 and do like 4 clicks at a time, or maybe 3, since we're only going up or down by 10. Do basically the scroll wheel, but we'll do 3 clicks at a time instead of 1. And then we can restrict it, which could be done in 2 lines or 1 line, but it looks a whole lot cleaner if we clamp it. So in our math library, there's a function for clamp. Has anybody ever used the clamp? It just sets bounds, sets an upper and lower bound, which is what's on the top of my screen right there right now. We want to clamp current zoom to be between min zoom and max zoom. So the value we're limiting, lower bound, upper bound. It's a really easy one, and that's one we do a lot. So then we can just do our math freely, and then on the next line, just check to make sure we didn't pass our bounds. And when we do, now that we have a zoom, we want to use that to change our offset. What have the offset say here? Which this looks like I never assigned it in the code, so I must have done that otherwise. But we'll take our offset and adjust it by that current zoom scaling factor. So instead of 1, 1, -10, we'll multiply everything by something between 1 and 20. Which means this is probably way too big. might need to come back and set our offset smaller to begin with. Okay, yes, so that offset is way too far out. As we move left and right, we rotate around our character and the scroll wheel gives us better angles on it. And then we could adjust those numbers further, get some up and down movement as well. Whoops. Let's see what this does. Don't know why it did that. Okay, so that's still way too far out. How far in do we zoom that? So there's all the way zoomed in. So probably need something even smaller than that. I'll set the offset to little bitty values. In each direction. So if we wanted to be a little bit above it, we're not really changing our Y, are we? I'll move up to a higher angle. Let's see what this looks like. Okay, that's still way too far out. I'm gonna go back to this 1.0 3 -2. So just some random camera position, and I'm going to change these to floating point numbers. So the current zoom is 0.1 and a minimum of 1 and a minimum of 0.1 and a maximum of 2.0. That's probably going to be way too far out. A maximum of 0.3. So I'll set the vector where we had closer to what we had originally and just make like percentages for our zoom amount. Perhaps that makes sense in the logic. Uh-oh. Oh, F. Oh, F. Okay, so that's way too far in, and it appears we're in the wrong direction. Our spinning still works. Y'all know the process here. So -3 there and 2 there. Let's see what that starts at. So probably need to add a 0 on those. Well, maybe this will work. I think this is going to be way far away now. Sometimes it takes a little refinement. Oh, that might work better. So there's the maximum and minimum. So that gives some at least a start and a change of view. And as we move back around, we can adjust how our view sees how we're looking at our character. Oh, and I wasn't paying attention there, but you can see those sort of basic ideas on how we set up those camera follows. It's an important thing in logic for game development in general, and obviously something you'll want to play around with, because that's the core, the stripped down, most basic version that we would need to do those things. Obviously, the zooms would work very similar. The zoom is just a scaling factor. We just pick a number and then we just multiply our offset by that number to say how far away our camera is. And then that rotate around, that's definitely 3D. But, here's our focal point. We're not going to change, we're rotating around the vertical thing. So it really is y'all. And I just went ahead and used y'all. But we do have to explicitly say which axis we're rotating around. So this will always be one of the basic ones, like vector 3 up, vector 3 down, left, right. One of our basic axes, or I guess you could put a more complicated vector going off at some angle if you needed to for your situation. And then yaw is just the proper term for what we're rotating around. Then we use our various inputs to adjust that. Spinning based on what the mouse X position is, or use the scroll wheel to adjust how far zoomed in or out we are. A very common one would be to use up and down for the zoom in and out, and left and right for the rotate. But our book never uses the scroll wheel anywhere, so I wanted to make sure and use that somewhere. And if you just change that to a Y, you would get that normal up and down stuff, which I guess I could show. Just one letter change there. So now instead of the scroll wheel, if we move our mouse in and out, but we probably don't want to do ×4 with that. That seems awful. That seems to jerk quite a bit. But we get that different control moving in and out. Yeah, probably not ×4 with that. You can see how same thing, but none of our examples have used the scroll wheel, so I wanted to make sure and include that, and include scrolling as a control somewhere, because the book never uses that. But that's the basic idea. Logic-wise, most of our engines, we have to script this out. Unity has an extra tool that's much easier to work with, but this one might take a little bit of practice. So maybe practice this tonight, and then in Monday's class, we'll look at the easier tool. It's called Cinemachine. Some of y'all may have seen it before. I think several people had Zach Hamby in the 148 class. He's the one that showed me Cinemachine. So I know he knows about it, and I assume he used it in your all's 148 class. It makes things a lot easier, but most of our game engines don't have that fancy tool, so we end up having to do things like this. Which, remember, the key one was just where are we trying to get to, then offset our camera a little, move there, and probably do some linear interpolation so that our character can move quickly, but our camera moves slowly. And then adding in selection structures to limit it and other little features that we might want in there. That's the basic idea of camera follows. It'd be very important in just about any game, unless our game is a little bitty world where we're confined and we can see the whole thing fine without moving the camera. We probably want to move the camera around. Does anybody have any questions about this? The stuff from this evening. And then on Monday, we'll look at a Unity specific tool that is much, much easier. So come this way. Okay, I see a no about the questions. So I will upload these files to GitHub here in just a few minutes. I believe there was some questions. Tyler said he had some questions about his final project. So we'll look at those, but otherwise, if there's no questions, I guess that'll be it for this evening. And I will see you all on Monday. Give that camera follow in a script of practice, and then we'll look at the easier tool Monday, because most of our engines don't have the easier tool. Otherwise, I will be sitting here till 8:50. Yeah, till 8:50 our normal time, ready to answer questions, jump back in a Zoom call if needed. As always, text messages and Ivy Learn messages are two things that make noise on my phone. And please use our time productively. We have 50 minutes left on schedule, and camera follows are a good thing to practice during this 50 minutes we have left. So please use our time productively. I will see you all on Monday. Everybody have a good evening. Stop recording.